day 10. So we've got a sort of virtual machine here. And it's got a set of, the input's essentially a list of instructions. And you go through and you execute the instructions, and it changes a state variable X, so kind of register. The quirk is that the addX instruction takes 2 cycles to run. So the first cycle it's read, and the second cycle it is actually applied. And since addition is, what do they call it? Commutative? I don't know. Addition has the property that this, the order doesn't really matter. So we can ignore any problems to do with that. Also addX, the value can be negative as well. And so in principle, this looks reasonably straightforward. There are a few quirks. One, of course, is the it taking 2 cycles to execute. So this is after 2 cycles, right? Yeah, so it gets read, it waits a cycle, and then it applies. And another quirk is that I suppose execution takes longer than the number of instructions. So we'll have to keep executing after the program is concluded. Let me start writing these down, these sort of quirks. And execution will continue for up to 2 cycles after the end of the program, due to the time it takes for addX to complete. And so we're interested in the value of the X register throughout execution, which is which we're going to use to calculate the signal strength, which is the cycle number multiplied by the value of the X register. So and we're going to look at this during the 20th cycle and every 40 cycles after that. So I guess this means, it's saying during, and I'm not 100% sure. It says during here, and then after the 3rd cycle. So so this is nothing. This at the start of the 2nd cycle. So actually, I've got this wrong. At the start of the 2nd cycle, the addX 3 instruction begins execution. During the 2nd cycle, it's still 1. During the 3rd cycle, it's still 1. And then after the 3rd cycle, it finishes execution. So it's read, skip, applied, sort of, red during is, there's this notion of during. Let's just get that. State is different during, well, during and after cycles. And we're interested in during. So here, for example, during the third cycle, that's what we're interested in. So really kind of at the start of the third cycle. And then we've got an example program here. During the 20th cycle, register X has value 21. So the signal strength is 20 times 21. The 20th cycle occurs during the middle of the second add X minus 1. So the value of register X is the starting value 1 plus all of the other add X values up to that point. So in principle, we could zoom to any moment here and sort of backtrack to work out what the cycle was. But that's probably not actually interesting to do unless the input's very large. 60th, 220th. How big is the input? Not very big. So we don't need to worry about that kind of efficiency. Not very big, though. I mean, that makes me very suspicious about what we're going to have to deal with next. My suspicion is that the number of cycles that an ADX takes will extend in some way. So we can sort of take some inspiration for our implementation from maybe my notional understanding of how a real processor would work. Of course, when I say real processor, I'm talking about a sort of simplified processor. Processors these days have all kinds of pipelining and all sorts of stuff, as we know from various security issues. So, but I do have a sort of notion as to how a processor works, in that there is a what is it? Fetch, decode, execute, or something. Let me Google that. Yeah, fetch, decode, execute. Let's see, what is that? 8. So we've got that sort of idea, and we've also got the idea of, I guess we could call it microcode, that higher level instructions are broken down into lower level instructions. And that's, in a sense, why some instructions take more than one cycle, because they're actually being broken down into smaller instructions. So in principle, we could decode this into a NOOP, let's say load 3, apply X, load -5, apply X sort of cycle. And then the way this would work would be, let's track X here, and let's track let's say load. So in this case, X would, I guess X starts off as 0. We can probably assume that. We load, so we 0, and then we load 3 into here. And then we next step apply 3 into here. which is takes out of load, and then we load -5 into here. And then the next step we apply it. So that in principle, well, it's actually 3 minus 5. Come on, K. -2. So we end up with -2 at the end, right? No. What have I gotten wrong here? Oh, X starts off as 1. That's what I got wrong. Silly assumptions. Yeah, so we end up with a kind of expanded code, which we then run through. And that kind of, well, that solves that problem, right? If we could use this approach. The only issue is, what's the value of X within in this cycle during the addX5 cycle? Well, actually, no, this doesn't work, does it? This doesn't work because because apply X is going to happen in parallel with load -5. So let's just kind of model this out a little bit. Let's say we've got a pre, during, post. We've got these columns. So pre this, it's 1, during this, it's 1, and post this, it's 1. Pre this, it's 1, during this, it's 1, post this, it's 1. Pre this, it's 1, during this, it's 1, post this, it's 4. And then we've got 4, 4, and then -1, and we can need a cycle number as well. 1, 2, 3, 4, 5. And we are interested in the durings. So here we've got during the second cycle, during X is 1, during X is still 1, during X is still 1, during the fourth cycle, 4. So it's 1, 1, 1, 4, 4, -1. One, 1, 1, 4, 4, 1. 1, 1, 1, 4, 4. Okay, what have I got wrong here? 1, 1, 1. Yeah, that's right. 4. Okay, I get it. No, I don't. 1, 2, 3, 4, 5. 1. Oh, okay. So there's no overlapping actually. Yeah, they're blocking. They're blocking. So actually this is right. So we've got I suppose this is an interesting facet of instructions, is they do have a pre and a post. So we've got pre 1x, post x. So what are these? We've got pre-x here, preload. No, that's nothing. Post-x, post-load is 3. Pre-x is 1. Preload is 3. Post-x is 4. Post-load is nothing. Pre-x is 4. Preload is nothing. Post-x is 4. Post-load is -5. Pre-x is 4. Preload is -5. Post-x is -1. Post-load is 0. Okay, so this works. As long as we don't need any overlapping, this works. And then we get during by looking at the start of an instruction, essentially, the pre. So we get 1, 1, 1, 4, 4. And then we kind of have an extra, you know, if we wanted to get the last one off. We could add a loop to the end and then look at the 6. So 1, 1, 1, 4, 4, minus 1. 1, 1, 1, 4, 4, minus 1. And so we're looking at this we're looking at, oh gosh, that's not helpful, is it? We're looking at this one. This one. We're looking at this one. And we're kind of looking at this one. 1, 1. Well, actually, no, we're looking at all of them. We're looking at all of them. Because they're all cycles. They're just not all instructions. Okay. And then we want to look at like a number at a certain point. Fine. Okay. Okay, so this would work, I think. The thing that I'm starting to think, so when you're planning, and when you're planning in a business context, one of the parts of planning is to plan what could go wrong, what could change, what might we need to attend to. I'm going to speak to this tomorrow, or like I'm going to do a kind of days 1 to 10 sort of exploration of my process today or tomorrow, just to see if I can make any tweaks. But one thing I know I'm going to say is planning process is great, but I want to work out a few things. What could make it easier for me to. I'm sort of handing over from like quite a planning mode to a very codey mode, and the planner isn't necessarily thinking of the ergonomics for the coder, and so I'm going to try and plan in more opportunities to give the codey version of me more information through which to code more efficiently and effectively and to see bugs quicker. So I need to think about how will I make this visible? And the output I sort of want to see is cycle like instruction cycle during, well, it's not really during, it's like start X, start load, post X, post load. And I want to see this in a table. So I've got to have this tabular format. That will be very handy for me. Or rather, instruction cycle micro start X, start load, post X, post load. So I want to see this, and this is going to help me actually probably even that would be maybe nicer. And I can sort of track across. And what if in the next step we're asked to do concurrency, or rather parallelism, I think. In which case, and I think we possibly could be asked to do that, in which case we would need to essentially keep track of jobs in progress, and then kind of just keep unfolding them. So we'd want to keep like a list of, really there's only going to be, well, there might be many in progress, I don't know. But we want to keep a list of processes going on in the background, and then every tick we would pull something out of that process. In which case, load will become difficult to manage, because load, I don't know what it could be, but load could end up being like, have like 5, 10, 15 things in at once, and that would be really difficult to manage. So the way I'm thinking about doing this is with generators, where you've got a sort of, you yield within a function once or multiple times, and then it kind of concludes. So let me try and research those. Real Python. Okay, so when they're done, they just raise an exception. Is that true? Ugh. All right, if you say so, Python. So I'm not a huge fan of using language elements in this way. It's nice when the program fits it, but when we don't know what the program's going to do next, it's a little bit, what if it works in a way generators won't work? So we might have to just plan to sort of shift away from generators if we need to. But let's say we were to go with generators, each instruction could, we could call a generator and we could keep calling it until it's done, incrementing the cycles as we go. And what would it yield? We might not want to really screw ourselves over by introducing a lot of memory usage, so it might just yield nothing and alter the state of a dictionary or something like that, which would probably work. Okay, so in terms of an algorithm, go through each instruction. Right, iterate. Don't need that. Over a generator for that instruction. Populating, or so it's like create a state dictionary, iterate with the generator for that instruction, and we want to capture the state pre each cycle, right? So this is actually one of the areas that I've been finding challenging, is the capturing of the right data as the algorithm goes on. So we could just capture every, like the state at every cycle. And if the generator yielded the state, we could just capture the state sort of at the state of each cycle. So actually, the generator could change the state, or could duplicate the state and then return a new one. And then we could store that in a list. Store in the list. and then we can print it out at the same time. So we can yield the pre and the post state. That would be quite good, be quite handy. And then at the end, yeah, what is it going to be? 20th cycle, and every 40 cycles after that. Okay. And sum, then you win. Okay, I think that will work. So in terms of the plan of action, we've got, well, in terms of the structure of the program, let's say, we want to we want I guess that or something. Anyway, great. And then we want that, and we want store and log pre and post. And I think that's everything we need. We need then a calculate, which is going to go through. It's going to go through, it's going to read the file line by line. It's going to get each instruction. It's going to go through each instruction, parse them into I'm going to go to parse line. Make things easier. Calculate, it's going to loop over each instruction, loop over each line, call parse line. and it's going to track the cycle, which actually the cycle is going to be in the state. I'm going to keep the cycle in the state. So the generator has to capture the state's going to look like X load cycle I think it starts at 1. Yeah. Great. Okay. Okay. And so in terms of a plan of action, we're going to drive out store and log, drive, run, noop, drive, run, adx, drive, pass line, drive some points, drive, calculate. Okay. Let me organize this a little bit. Okay. Let me open up the Python generators docs. Okay. And to VS Code. Let's get the input, which isn't that long, by the way. It's very short, actually. See, only 440 lines. And we'll get the longer trial code, which is going to be come out to be 13,140. And then we can get started. Why do I do this? Okay. Yeah, that's right. 13,140. Okay, we don't need that yet, but we will. Okay. Okay, I'm gonna need to add some different stuff into here. Cycle, micro. Okay. Don't quite know what's gone wrong here. Oh, can you not? Oh, that's so irritating. I think it's that. Okay, let's try that out. What was that tool that I got recently? That's better. Yeah, nice. Nice. Okay. Wow, I thought you could access from outside. Oh well, guess you can't. Whatever. It's not important. Getting distracted. Okay, great. Okay. See, I should have thought ahead. YIELD. Yeah, I think that's it. Okay, great. And actually, this is going to need to yield a different thing. It's going to need to yield the instruction, which is noop. The microcode instruction. So it can be logged. All right. And it's going to need to be a thing. I should have modeled this out in advance. Are those not comparable? Yeah, I think they're not comparable. Oh well. Oh no, wait, they are comparable. It's just I'm looking at the wrong line. Yeah, okay, fine. So this one wants to have we want to yield load and then the number, and then the new state, which should have the cycle +1 and the load set to the number. And then we want to do the same thing here, but in this case, set X to load and then set load to none. And then yield this. What do we call that? Apply X. Okay. And what we want to be putting across is and then I don't know what's up there. Oh, is that? There we go. Okay, we want to get apply X with no argument the cycle being 3 at this point, x being 2 minus 2, and load being none. But it's not that. I think we just want to actually just call this a list. I think that's what we want. Load minus 4, cycle 2, x2, load minus 4, apply x, cycle 3, x minus 4. Yeah, okay. So I got this wrong. There we go. Okay, great. Need to speed up a little bit. Just going to return this. I think that's a little bit easier to deal with. Okay. Okay, I just want to test the logic here. So I'm going to do this slightly awkwardly. So this should get, so this should get this one, 2 plus 5 plus 8, 15. It doesn't, because I need to start at plus 1, and I'm currently getting that minus 1, 2, second, fourth, and eighth. So that's right. And we need to actually go on one further. Or not, seemingly. Why are we not getting the last one? Okay, this is really getting slightly out of control here. I shouldn't be struggling with this bit. Okay, I'm going to ditch this. I'm going to come back to it if I need to. Okay. Okay, storage, instruction, cycle being the state cycle, micro being minced, pre-state being state, and this being post-state. And then state equals post-state. And then store and log, come on. Okay, and then at the end, come on. Okay, let's just work through this. Okay, so the pre-state is, so this is cycle 21. So we want 19 actually, cycle 20, x is 21 times 20, making, it's actually not going to be that, it's going to be post state x. Okay. So this is our first, and then the next ones are going to be for true. Okay, total equals lines start is 1 times start okay, we're at okay, too far. Okay, now input not the right answer, too high. Okay. What can we do in this time? Okay, 20th, 60th, 100, 220th. I think this is a loss, you know. Only 30 seconds remaining. I've made an error. Nope, too high. That's that. First loss. Oh gosh, and on such a apparently simple problem. Okay. Hmm. All right. Okay. Well, let's pick this up then. I'm not going to spend too long on it, but let me just try and work out where my mistakes are. First mistake, obviously, is this really didn't help me as it should have done, because I didn't model the data structure for the instructions properly. That was the first thing that started to go wrong. So this should just be, this was annoying. So like the instructions probably should be in like the form of a string or something. Because I just made this too complicated. See, that's just stupid. Apologies, bad language. So you can't join. Okay, fine. Some reason you got to do this, and then we'll need to do the same with the micro. And then this didn't work for some reason, probably because it's upset. It's not tolerant enough. Come on, loghead. Okay, so on the trial, this came out with the right answer. Let's finish this thing, which for some reason I found very difficult to actually, come on, very difficult to actually get done. I don't know why. I can just make this simpler. It's actually going to be 19. There are some off by one errors here. Uh, and this is going to be 59, 99, 139, 179, and 219. So at this point, we should be able to get the right answer. That doesn't help, does it? So this is wrong in some way. And it's not very tolerant, this program, is it? 113. Oh yeah, and it's got to be multiplied by the cycle number. $13.40. Will this help? Okay, 13,140, and then let's try it on the input. Yeah, well, that's a different number, isn't it? Is it right? Yes. So it's just silliness. It was all preventable. Okay, well, that one's a loss. Okay. I knew it was going to happen. First loss of the challenge. Okay, let's look at part 2. See if we can try and get this at all. The X register sets the horizontal position of the middle of the sprite. You count the pixels on the CRT. CRT is tied closely to the clock circuit. The CRT draws a single pixel during each cycle, representing each cycle with a pixel. If the sprite is positioned such that one of its 3 pixels is the pixel currently being drawn, the screen produces a lit pixel. Otherwise, the screen leaves the pixel dark. The first few pixels from the larger example above are drawn as follows. Okay, so right. So if we go through each one, we've got 240 cycles, and we've logged them all, so we know what it is. And we can go through essentially 0 to 240, tracking along the execution state. And if the pixel being drawn is if the pixel being drawn is one below or one above or the same as the current state of X at the beginning of the state, then we draw a bright pixel, otherwise we draw a dark pixel. So in a sense, the way to get this is to iterate over each cycle if cycle is if cycle minus pre-x, so let's say pre-x is 40 and we're on cycle 39, then 40 minus 39 is 1, whereas if we're on cycle 38, 38 minus 39 is 1. So if it's sort of greater than -1 is within -1 to 1, draw bright, otherwise draw dark. If cycle divisible by 40, draw new line. And this gets us our answer, I think. So should be able to do that. Let's get going. I think my rules state that I've lost the day, so doesn't really matter, but let's get started. Let's get rid of some of this stuff. And then let's not use this thing. For Do we store the cycle? Yeah, I think we do. Minus do we have abs in Python? Yeah. Yeah. Well, the first line is kind of right. Lines after that aren't at all. And this isn't right either. So the first line is supposed to be this, and we've actually got this. So we're right for the first few. This logic might be wrong. Oh yeah, I've missed a requirement, I think. The X register controls the horizontal position of a sprite. So we actually are interested in the remainder. And there's still a little bit of a problem here. and it goes wrong, here. Yeah, that's where it goes wrong. So let's take a look at that. 2. Ten. So cycle 10, we're drawing in position 9. So I think this one needs to be maybe +1, I think. No, -1. I'm just guessing now. Well, it does get us there. Let's see. How does this help? Well, what am I doing here? Why am I messing around? What is going on? That one doesn't work. Oh, I'm getting irritated now. Okay. Well, that seems to be the right answer. Apart from this. This one's wrong. So we draw in position 0, cycle 1, and then we want to find out what's the state of X at the time. And then we get all the way to the end. Then what happens next? We go on by 1. We shouldn't be going on by 1. Okay, now let's go through line 2. This one's not right. We've got cycle. So on cycle 21, okay, so we end up, wait, they're not even 20 lines long, they're 40 lines long. Okay, let's compare these two. That's right. Okay, let's go to 80 and compare the second line down. Come on. Why is it so long? Why are you so long? Anyway, what have we got here? That's right. It's just not. Why is this ending up? $39. 30. Okay, now let's try all of them. Okay, so first line, second line. Is the third line right? Yes. Is the fourth line right? Yes, is the fifth line right? No, that one's wrong. And is this one right? Yes, so this one's wrong. It's wrong just on the end here. Maybe it doesn't matter. Let's try it. F, C, J, A, P, J, R. What's that? B? That'll be B, because this one's wrong. For some reason, that exit line is wrong. I don't know. I don't know why. It doesn't seem to matter. F, C, J, A, P, J, R, B, I think. F, C, J, A, R, no, P, J, R, B. F, C, J, A, P, J, R, B. Yeah. All right, let's find out. That's not the right answer. Okay, interesting. F, C, J, A, P. What did I put again? F, C, J, A, P. F, C, J, A, P, J, R, B. And we've definitely got some errors in here, don't we? Okay, back to the trial. This one is wrong. What is wrong with that one? What is it just that it's at the end of the line? So this would be cycle 200. So we're at -1 in the H pos. Yeah, so we should be able to get to this number, I think. That's going to mess it up though. Maybe I just take this off. So we should be going from the cycle should go from 1 to 40 in step here, which it is. 0 to 4, yeah, at 80, 81. So 41 should be H pos 0, which it is. 81 should be H pos 0, but it's not. 41, 80 should be, what? How is that? Okay, cycle 1 should be H pos 0. Oh, god damn it. I've started from the wrong number. Cycle should be 1 less than it actually is. Okay, so 0 through to, so cycle 1 should be H pos 0. Cycle 40 should be H pos 40. Five should be 4. 39 should be 38. 40 should be 39. 41 should be... Okay. 0, 39. Okay, 80 should be at the end, 81 should be at the beginning. Okay, great. Now, for some reason, we've not got any data anymore. So that's interesting. Because we're not getting a new line. Okay, is that right? I think so. That's better. Okay, let's try it with the real one. F C J A P J R E. Well, that is different. F C J A R, no, P J R E. That's right. Okay. First loss. Well, tomorrow or today, I'm going to have a run through of my experience so far in this challenge and what I can take from particularly today's travesty. And hopefully this will be the last loss for a little while, at least. I don't know how I'm going to cope with the sort of as we get into the 20s, but we'll see. Laters.